Spruce Pine, a small town in the Appalachian Mountains, is crucial for global tech and supplies up to 90% of the world's high-purity quartz essential for semiconductor production. Hurricane Helen, which made landfall near Perry, Florida, in September 2024, has caused significant damage to the town, causing over 220 deaths across 6 southeastern states. The town's critical infrastructure has been severely compromised, with nearly 40% of homes and businesses in Mitchell County still powerless. The town's quartz mines, operated by Belgium-based Sibello and the Swiss-based Quartz Corp, have been severely damaged, with over 450 road closures and numerous bridges and overpasses destroyed. The main CSX rail line, which served as the primary shipping route for the mines, has also been heavily damaged. 2 companies, Sibello Spruce Pine Foundation and Quartz Corp, have halted operations on September 26. The company has established a $1 million Spruce Pine Foundation to support long-term recovery efforts, but Quartz Corp continues to face uncertainty about resuming operations. The high-purity quartz produced by Spruce Pine is essential for manufacturing crucibles used in silicon wafer production. The quartz from Spruce Pine demonstrates exceptional properties, such as superior corrosion resistance, minimal thermal expansion, high electrical insulation, and excellent light transmission capabilities. The semiconductor industry, valued at $588 billion in 2024 and growing at 133% over 2023, relies heavily on these properties. The quartz equipment sector alone represents a $2.12 billion market. Teshe CEO Lita Shah Roy emphasizes that Spruce Pine is the only plant in the world that serves the semiconductor industry in its entirety. If something were to happen to these plants, it could put the entire industry on its ear. Most semiconductor manufacturers maintain 2 to 3 months of quartz reserves, with some holding up to 8 months. Supply becomes critical when crucible leaf span, which typically last only 300 to 400 hours before requiring replacement, could be disrupted. Industry sectors ranging from automotive manufacturing to healthcare technology and renewable energy depend on semiconductor availability. The automotive industry could face significant production delays, while medical device manufacturers and industrial equipment producers might experience slowdowns and price increases. Alternative sources of high-purity quartz are being explored to ensure the safety and sustainability of the industry. The Spruce Pine mine in California has been severely impacted by a supply chain crisis, with 80 to 90% of the global supply coming from this location. Major semiconductor manufacturers have responded to the crisis by maintaining diverse global suppliers, and Samsung Electronics claims their operations remain unaffected. However, Ed Conway warns that it is rare for a single site to control the global supply of a crucial material, especially for high-purity quartz, which is needed for silicon wafers. The vulnerability of this critical supply chain has caught many by surprise, as it has been the source of high-purity quartz needed for silicon wafer production. The situation has led to President Joe Biden's planned visit to Asheville being canceled due to impassable roads. Recovery efforts face significant challenges, including extensive rebuilding of roads, power infrastructure, and communication networks. Local officials emphasize that larger population centers like Asheville must take priority in restoration efforts. The mining company's specialized workforce has been severely impacted, with many employees displaced or having their homes damaged. The community's isolation has made it difficult for both Sibello and Quartz Corp to maintain contact with their employees. Supply chains have demonstrated the potential for widespread impact, with a 2008 fire at a quartz refinery in Spruce Pine affecting only the Uniman Corporation quartz feldspar plant now owned by Sibello sending shockwaves through the global market. The timing of this disruption is particularly concerning as Silicon Valley giants pour billions of dollars into chips for artificial intelligence systems. The semiconductor industry's emergence from its own recent downturn means demand has been relatively soft, providing some buffer. However, some experts remain cautiously optimistic, suggesting that the mine is considered a national strategic asset and the federal government will move hard to get it up and running as quickly as possible. The impact on the tech industry will depend on how long it takes them to get operations running again. Most manufacturers have some level of stockpiles, so there will be some slack in the system if the issues are temporary. However, Chris Hackney, a researcher in human geography at Newcastle University, emphasizes broader concerns, such as the damage to infrastructure, roads, transport power, and mining equipment, which could stop production for a while. Any disruption to supply chains will have an impact on prices and production of high-end electronics and technology. China's semiconductor industry is experiencing a significant leap in technological capabilities, with the company completing the tape-out of its first 3-nanometer smartphone system on chip. The announcement came from Tang Jiangou, chief economist of Beijing Municipal Bureau of Economy and Information Technology. This development places Xiaomi among an elite group of global technology companies capable of developing 3-nanometer chips. The path to the current 3-nanometer breakthrough has not been straightforward, as the adoption of 3-nanometer process technology significantly impacts manufacturing costs. This cost increase has direct implications for the pricing of Xiaomi's flagship phones, reflecting the substantial investment required for cutting-edge semiconductor development. Technical specifications of the new 3-nanometer chip remain partially undisclosed, creating significant industry speculation. The successful tape-out confirms the completion of the design phase, but crucial details about the CPU cluster GPU implementation and whether the chip will utilize ARM designs or a custom architecture remain unknown. Industry experts note that successful tape-out at 3 nanometers requires advanced electronic design automation and sophisticated simulation capabilities. The combination of advanced process technology and security implementations could provide Xiaomi with significant advantages in enterprise and security-conscious markets. Making partnership considerations play a crucial role in this development, with TSMC emerging as the likely manufacturing partner due to several key factors. Unlike SMIC, which lacks 3-nanometer fabrication capabilities, TSMC possesses the necessary technical expertise and production capacity. Additionally, XOM's position outside the U.S. entity list enables access to TSMC's advanced manufacturing services, a significant advantage compared to companies like Huawei facing strict trade restrictions. At the 2024 Snapdragon Summit in Hawaii, Xiaomi announced that its 15 series would be the first to feature the Snapdragon 8 Elite chip. The company's parallel development of its 3-nanometer chip suggests a comprehensive approach to future device capabilities, with the Xiaomi 15's Pro targeted for a 2025 launch featuring this breakthrough. The Xiaomi 15 series is set to be the first smartphone powered by Snapdragon, a global leader in the industry. This development is significant as it represents a step forward in developed technology and demonstrates Xiaomi's commitment to in-house chip integration across its product ecosystem. The upcoming devices featuring the 3-nanometer chip will run on HyperOS 2.0, Xiaomi's newest operating system. This software platform promises enhanced security features, improved animations, and advanced multitasking capabilities. The market implications of this development extend beyond Xiaomi's immediate product line, potentially enabling other Chinese companies to access this technology. However, the complexities of international trade regulations and intellectual property considerations remain significant factors. Qualcomm's current strong position in the Chinese market with over 50% year-on-year revenue growth from mainland smartphone makers adds another dimension to this evolving landscape. Memory costs present an additional factor in the broader market impact. Beyond the 3-nanometer chip adoption, memory prices have reached peak levels after a year of continuous increases. This combination of advanced chip production costs and rising component prices suggests significant implications for consumer device pricing across the industry. The verification status of this development remains a point of discussion within the industry, with Tang Jiangou's announcement carries the weight of his official position. Xiaomi's measured silence on the matter reflects the sensitive nature of advanced semiconductor development in the current geopolitical climate. Industry watchers await potential confirmation from Xiaomi founder Junle, particularly given the technical complexity involved in 3-nanometer chip production. The technical advancement from 28-nanometer to 3-nanometer represents a remarkable leap in semiconductor manufacturing, placing Xiaomi's capabilities near industry leaders like TSMC and Samsung. The achievement is particularly noteworthy considering China's limited access to extreme ultraviolet EUV lithography equipment from ASML. Performance expectations for the new chip suggest capabilities comparable to current flagship processors. The manufacturing process involves several critical stages beyond the initial tape-out small batch production for testing yield rate optimization and potential design modifications. Experts emphasize that successful high-volume production at 3 nanometers requires extremely precise process control and sophisticated quality management systems. Looking ahead to 2025, the Xiaomi 15's Pro is positioned to showcase this technological achievement, integrating advanced AI features, enhanced battery management systems, and improved processing capabilities, all optimized through the combination of the 3-nanometer chip and HyperOS 2.0 operating system. This development has particular significance for Xiaomi's artificial intelligence capabilities, as advanced node processes are crucial for implementing sophisticated AI features in mobile devices. China's semiconductor industry has evolved significantly over the years, with the introduction of advanced chip technology and the integration of proprietary 3-nanometer chips. This has led to a competitive positioning in the global smartphone market, as Chinese companies are not subject to US trade restrictions. However, some mainland AI chip design firms have reportedly adjusted their specifications to comply with Washington's computing capability restrictions. The integration of proprietary 3-nanometer chips could differentiate Xiaomi's offerings in increasingly competitive markets. The impact on global semiconductor supply chains is particularly important, as Xiaomi joins the ranks of companies capable of producing 3-nanometer chips. This could influence how other technology firms approach their semiconductor strategies, potentially accelerating the trend toward in-house chip development. China's semiconductor ecosystem has evolved from the initial development of the Surge S1 in 2017 to the current 3-nanometer breakthrough. The 7-year gap between major SoC releases suggests a methodical approach to capability development rather than rushing to market with intermediate solutions. The role of domestic semiconductor policies becomes increasingly relevant, with Beijing's investment in the sector reportedly reaching tens of billions of dollars. However, the interaction between domestic capability development and international technology access remains complex, particularly given ongoing export control regulations. Market analysts note that component suppliers may face difficulties as Xiaomi develops more in-house capabilities. However, the company's continued partnership with firms like Qualcomm for current products indicates a balanced approach to technology sourcing. Bluetooth Near Link, also known as SparkLink, is set to redefine wireless technology with 6 times faster speeds, 60% less power, 10 times more device connections, and ultra-low latency across a 600 m range. Near Link offers several significant advantages, including lower power consumption, higher speed, 130th delay, and support for 10 times more network connections. Near Link's extended transmission range is particularly noteworthy, enabling seamless transmission of large files, high-quality audio and video, and supports data-intensive applications. It also excels in terms of the number of connectable devices it can support, handling up to 4,096 devices connected simultaneously and processing data from 80 users within a millisecond. In conclusion, China's semiconductor industry has experienced significant growth and development, with the introduction of advanced chip technology and partnerships with companies like Huawei. Near Link technology is a low-power, low-latency, and high-reliability technology that focuses on high-speed, high-capacity, and precision applications such as video transmission, large file sharing, and precise positioning. It offers data transmission rates of up to 12 megabits per second, supports bidirectional latency of 250 microseconds, and allows simultaneous access by 256 users with a power consumption of less than 2 milliamps. The physical layer of Near Link technology consists of 3 main layers: the physical layer, the data link layer, and the network layer. The physical layer handles the transmission and reception of high-frequency signals, while the data link layer handles packaging, unpacking, data validation, and error correction. The network layer ensures data is correctly transmitted to its intended destination. Huawei has developed 2 Near Link modules, H383U and H383s, which support various protocols and communication interfaces. Both modules support the coexistence of Wi-Fi and BLLE, allowing for flexible integration into various devices. Applications of Near Link technology are vast and varied, including consumer electronics, smart homes, electric vehicles, industrial smart manufacturing, smartphones, PCs, cars, and other devices. In the automotive industry, near-link enables high-speed, high-capacity, low-latency, and high-precision connections and interactions between cars and mobile phones. For smart industry applications, near-link allows industrial robots, sensors, and controllers to achieve high-speed, high-capacity, low-latency, and high-reliability connections and collaborations. Users can remotely monitor and control the operating status and data of industrial equipment through mobile phones or tablets. Near-link technology also enables collaboration between equipment, improving production efficiency and quality in smart wearables. N-Link technology enables devices such as smart watches, bracelets, wireless earphones, and smart home applications to achieve low power consumption, low latency, and high reliability. Users can remotely control various devices at home through mobile phones or voice assistants, enabling intelligent life scenes and device linkage through near-link technology.